everyone, my name is Shirley and welcome back to my channel. In this video, you will learn about the concept of radian, finding arc length of a circle, finding the area of a sector of a circle, and application of circular measure. Let's get started. What's the meaning of circular measure? Circular measure is the measurement of angle in radians. We usually measure an angle in degrees with a protractor. However, mathematicians prefer to measure angles in radians. What is a radian and how much do you know about radian? The radian is a standard unit of measure for angles, particularly in trigonometry. 1 radian is the angle subtended at the center of a circle by an arc that has an equal length to the radius of the circle. As you can see, the radian is the ratio of the arc length to the radius. As a ratio of two lengths, the radian is a pure number that does not really need a unit symbol. So how much is 1 radian? So 1 radian is equal to approximately 57.29 degrees. How do we calculate this? So pi radian is 180 degrees. Therefore, 1 radian is 180 divided by pi. And we take pi equals to 3.142. So 180 divided by 3.142 will get 57.29. Therefore, it's easy to convert between radians and degrees. To convert from radian to degrees, we multiply by 180 degrees over pi. And to convert from degrees to radian, we multiply by pi over 180. Now let's look at this table. So this table is for common angles. Okay, for example, when it's 0 degrees, so it's 0 radian. When it's 30 degrees, so it's pi over 6. Okay, and when it's 45 degrees, it's pi over 4. When it's 60 degrees, it's pi over 3. When it's 90 degrees, it's pi over 2. So when it's 180 degrees, then it's pi. Okay, when it's 270 degrees, therefore it's 3 pi over 2. When it's 360 degrees, therefore it's 2 pi. So it's necessary to memorize all this, okay, so that when it comes to exam, we can easily find the answer in radian without even using the calculator. And sometimes the answer might require you to give your answer in terms of pi. Okay? Let's look at this example. Number 1, convert 2.5 radians to degrees. So to convert to degrees, we have to multiply by 180 over pi. Okay, let's solve this for number 1. So 2.5 radians is equals to 2.5 times 180 degrees over pi. And we take pi equals to 3.142. So equals to 2.5 times 180 over 3.142. And then we calculate with the calculator and see what answer we'll get, okay? So 2.5 times 180 divided by 3.142. So we'll get 143.2 degrees. So 143.2 degrees. So that's the answer for number 1. Okay, now let's solve for number 2. Okay, convert 305 degree to radian. So to convert from degree to radian, we have to multiply by pi over 180. Okay, so for number 2, so 305 degrees, so we convert, so 305 degrees times with pi over 180. So it's equals to, 305 times, 3.142, that's the value of pi, over 180. So it's equals to, okay, let's calculate with the calculator. So 305 times 3.142 divided by 180, so we'll get 5.3239 radian. So it's 5.3239 radian. Okay, so that's the answer for number 2. So now let's solve for number 3. Okay, for number 3. Okay, convert 110 degree 30 minutes into radians. Okay, for number 3, so 110 degree 30 minutes. So 110 degree and 30 minutes, we change it only degree. So 30 minutes means it's 0.5 degree, half of a degree. So which means it's 110.5 degrees. Okay, so after that we change to radian, we multiply by pi over 180. So 110.5 times pi over 180. And pi is 3.142.
Okay, so 110.5 times 3.142 over 180. Okay, let's calculate this. Okay, 110.5 times 3.142, then divided by 180, so we get 1.929 radian. So 1.929 radian. And that's the answer for number 3.
What is an arc length of a circle? An arc is any portion of the circumference of a circle. The length of arc, or the arc length, is usually represented by the letter S. In this diagram, the arc AB subtends an angle theta radians at the center of a circle of radius r. The length of arc is proportional to the angle it subtends. Therefore, we have minor arc length AB over theta is equals to circumference over 2 pi. So therefore, S over theta is equals to 2 pi r over 2 pi. So when we move over the theta to the right hand side, we'll get S equals to 2 pi r over 2 pi times with theta. So therefore, S is equals to r theta. And this is the formula to calculate the arc length of a circle. So now we know how to calculate the length of arc of a circle, which is by using the formula S equals to r theta. So do you know that the theta must be in radians and not in degrees? So if the question gives you in degrees, you have to convert into radian first, okay? And what is minor arc and major arc? So let's look at this diagram. The minor arc subtends at the center angle of theta radians. So since a complete revolution is 2 pi radians, then the angle subtended by the major arc is 2 pi minus theta radians.
Let's look at these examples. To find the length of arc, which is S, we're going to use the formula S equals to r theta. And remember that theta must be in radians, okay? So let's look at question number 1. So calculate the length of arc S. So it's given that r is equals to 6 and theta is 60 degrees. So later we have to convert the degree into radian, okay? So first question, so S equals to r theta. The first step is to write down the formula and then we substitute the values in, okay? So r is equals to 6 and theta is 60. So when we want to convert from degree to radian, we have to multiply by pi over 180. Okay, so let's calculate this with the calculator. So 60 times 3.142 divided by 180 and then times 6. So our answer is 6.284 cm. So 6.284 cm. So that's the answer for number 1. Okay, now let's solve for question number 2. So calculate the radius of the circle. So we're going to use back the same formula, S equals to r theta. So S is equals to 5.95 and r is r and theta is 1.7. So to find r, we're going to use 5.95 divided by 1.7. Okay, so we'll get, okay, let's calculate this, 5.95 divided by 1.7, so we get 3.5 cm. Okay, so the answer for number 2 is 3.5 cm. Okay, now let's solve for question number 3. Okay, calculate the angle theta in degrees. So theta is unknown. Okay, so number 3, so we're going to use back the same formula, S equals to r theta. Okay, so S is 16.2 equals to r is 9 and theta is unknown. Okay, so to find theta, I'm going to use 16.2 divided by 9, so it's equals to, okay, so 16.2 divided by 9, so we'll get 1.8. So 1.8, this is in radian. But the question is asking, give your answer in degrees. Okay, which means I'm going to convert this into degree. So 1.8 times 180 degrees over pi. Okay, so I'm going to use the calculator. 1.8 times 180 divided by 3.142. So I'll get 103.12 degree. So 103.12 degrees. So that's the answer for question number 3.
So how to find the perimeter of a segment? To find the perimeter of a segment, we use length of chord AB plus with arc length AB as shown in this diagram. Let's look at the following example.
Okay, now let's look at this example. So find the perimeter in cm of the shaded segment ABC. So the shaded segment is over here. Okay, so in order to find the perimeter of the shaded segment, so we have to find the chord, the length of chord, and also plus with the length of arc. Okay, so let's calculate the length of arc first. So to find length of arc, I'm going to use S equals to R theta. Okay, so R is equals to 10 cm and your theta is already in radian. So it's pi over 3. So it's equals to 10 over 3 pi. Okay, so we just leave it as this answer first. And then next, I'm going to find the chord. So in order to find the chord, I'm going to use the cosine rule for triangle. Okay, in order to find the cosine rule, I'm going to use this AC square, which is the chord, equals to, so here is 10 and here is also 10. Okay, so 10 square plus 10 square minus 2AB, so 2, 10 times 10. Okay, and then times with cos. So cos is, so pi over 3 is in radian, but cos must be in degree. So we want to convert from radian to degree, so we have to times, okay? So we have to times with 180 over pi, okay? So we can cancel off the pi, so 180 over 3 is actually 60. Okay, let's calculate this. So this is 100 plus 100, we get 200, minus 2 times 10 is also 200. After that, cos 60 degrees. Okay, so let's calculate this. So I'm going to calculate cos 60 is how much first? Cos 60 and then times 200. After that, 200 minus the answer, I got 100. Okay, so 100, so that will be AC square. So to find AC, so I'm going to square root the 100. So AC is 10 cm. So now we can find the perimeter of the shaded segment. So perimeter of the shaded segment, okay, is equals to, so the length of arc that we found just now was 10 over 3 pi, okay, so plus with 10. So for this, I'm going to change this, okay, to become decimal by multiplying with the pi 3.142. So 10 over 3 times 3.142. So I got 10.47. Then after that, I plus with the 10, which is the length of the chord. So I'll get 20.47 cm. So 20.47 cm is the answer for this question.
So how do we derive the formula for area of a sector of a circle? Let me explain to you step by step. So area of minor sector AOB over theta equals to area of a sector over 2 pi. So A over theta equals to pi r square, which is the formula for area of a circle, over 2 pi. Okay, to find A, we move the theta over to the right hand side. So A equals to pi r square over 2 pi times with theta, and we can cancel off the pi top and bottom. Okay, so therefore we'll get the formula A equals to half r squared theta, and this is the formula to find the area of a sector of a circle. And remember that theta has to be in radians.
Let's look at this example. Determine the area of sector AOB with center O in cm square. So the keyword here is area of sector, which means we're going to use the formula area equals to half r squared theta. And remember that theta must be in radian, okay? So let's look at this question. Okay, this question is given in degree. So later we have to change this to become radian, okay? So first of all, I'm going to write down the formula first. So area of a sector AOB, okay, is equals to half r squared theta. Okay, so equals to half, r is 20, so 20 square, and theta, we have to change this to become radian, so times with pi over 180. Okay, and we take pi equals to 3.142. So let's calculate this with the calculator. Okay, here. So 135 times 3.142 divided by 180. After that, we times with 20 square, and then we divide by 2. So we get the answer 471.3. So 471.3, and the unit is cm square. So that's the answer.
How do we determine the area of a segment of a circle? So to find the area of segment of a circle, we use the area of a sector, which is half r squared theta, minus the area of the triangle. Let's look at the following example.
Let's look at this example. The diagram below shows sector MON of a circle with center O and a radius of 3 cm, means r is equal to 3. Given that the minor arc length MN is 5 cm, which means S equals to 5, and find angle MON in degrees and also the area of the shaded segment. So let's solve for A first. So what is the information that they give you? S and also R. So, okay, what is the formula for arc length? S equals to R theta. Okay, so I'm going to use this formula to find my theta. Okay, so S is 5 and R is 3 theta. So to find theta, it will be 5 over 3, and this is in radian. But in the question, they ask you to give your answer in degrees, which means that we have to convert the radian to degrees. So how to convert from radian to degrees? We have to multiply by 180 over pi, and then we take pi as 3.142. Okay, so let's calculate this. So 5 over 3 times 180 divided by 3.142, so we get 95.48. Okay, so 95.48, that will be the answer for A. Okay, now let's solve for B. Okay, let's solve for B. So find the area of the shaded segment. Okay, so to find the area of the shaded segment, you're going to use another formula. Okay, so area of the shaded segment. Okay, so I'm going to use the formula which is half r squared theta. Okay, minus, okay, half r squared theta is the formula for the area of sector. Okay, so minus the area of the triangle. So to find the formula, okay, what is the formula? To find the area of the triangle, we have to use the formula half r squared sine theta. Okay, so half r squared sine theta. Okay, so equals. So in this question, we already got our r, we got our theta. Okay, and sine theta must be in degree. Okay, so let's solve this. So half, so r in this question is 3, so 3 squared, and then this theta must be in radian. So radian is here 5 over 3. Okay, that we have found just now. And then minus half, okay, r is 3 again, square, and then sine. For this one, we have to use the angle in degree, which is 95.48. Okay, so 95.48. Okay, so let's calculate this. Take our calculator. So half times 3 squared is 9, and times 5 over 3. Okay, so we get 7.5. That will be the area of the sector. Then minus, okay, area of the triangle, half times 9, then times sine 95.48, and we get 4.4794. Okay, 4.4794, and then we minus. Okay, 7.5 minus the answer is 3.021. Okay, 3.021, and the unit for area is cm squared. So that's the answer for B. Let's look at this example. The diagram below shows the cross-section area of a tree trunk with a radius of 46 cm, so r is 46, floating on the water. The point P and Q lie on the surface of the water, while the highest point r is 10 cm above the surface of the water. Calculate the value of theta in radians, that arc length PRQ in cm, and the cross-section area that is above the water in cm squared. So let's look at the diagram. Okay, so PQ is the surface of the water, and then the radius is 46 cm. Therefore, this is also 46. Okay, so I'm going to split this into half, and I'm going to take it out so that you can see clearly. Okay, so this triangle, so this 90 degree, this is P, O, and this is a midpoint I put as M, so M. So let's say this whole thing, angle POQ is theta, so therefore angle POM is theta over 2. Okay, and OP is the radius, which is 46. And we need to find what is OM. Okay, to find OM is actually OR minus 10. So OR is the radius, which is 46. Then minus 10, we get 36, which means OM is 36. Okay? So we have to use trigonometry to find theta. Okay? Either we use sine, cos, or tangent. So see what they give you. They give you the hypotenuse, which is 46, the longest side of a triangle. And also, this will be the adjacent side. So adjacent over hypotenuse is cos. So we're going to use cos theta over 2 equals to A over H. Okay? So 36 over 46. And now we can use the calculator to find what is our theta. Okay? So we use shift cos of 36 over 46. So we get 38.5. Then after that, we times 2. So our theta will be 77. Okay, so 77 degrees. But they want you to give your answer in radians. So what should we do? We have to convert to radians. You have to times pi over 180. So 77 times pi over 180 degrees. Okay, so we take pi as 3.142. Okay, so we substitute in. So the answer that we get, which is 77 times 3.142, then divided by 180. So we get 1.344. And this answer is in radian. Okay, and that's the answer for A. Okay, now let's solve for B. Find the arc length. Okay, find the arc length PRQ. PRQ is over here. Okay, so we're going to use the arc length formula. Okay, so what's the arc length formula? Okay, I'm going to put it here. So arc length formula is S equals to R theta, right? Okay, so S equals to R theta. So we know our R radius is 46. Okay, and our theta that we found just now is 1.344. So we're going to apply it into here, 1.344 in radian. Okay, and then we calculate. So 46 times 1.344, so we get 61. Okay, again 46 times 1.344, so we get 61.824. Okay, 61.824, and the unit is cm. Okay, so that's the answer for B. Okay, now let's solve for C. Okay, for C, okay, find the area of the cross-section. So area of the cross-section is actually the area of a segment, okay? Area of cross-section. Okay, so what is the formula to find area of a segment? So we use the area of a sector, which is half r squared theta, minus the area of the triangle, which is half r squared sine theta. Okay, remember this formula, yeah? So equals to, so half r is 46 square, and then theta is 1.344. Okay, minus half. Okay, so r is 46 and then square. So sine, okay, this theta has to be in degrees. So what is theta in degrees? Okay, just now we found already 77. Okay, so 77, put it here. Okay, now we can calculate using the calculator. Okay, half times 46 square, and then after that we times 1.344. So we get 1,421.952. Then minus, okay, so calculate this, half times 46 squared, and then times sine 77. So you get 1,030.884. And then we minus, okay? So 1,421.952 minus the answer that we gotten just now. So we get 391.068. 391.068. And the answer is cm square, in cm square. And this is the answer.
Well, that's all for now. Do you wish to see more videos like this? Let me know in the comments below. Like this video if you like it and think it's useful. Share this video with your friends because sharing is caring. Subscribe to my channel if you haven't. And I hope to see you in my next video. Bye!